Hello, everyone. Good to see you all, and happy Saturday. It's a great time to maybe talk about some kind of math that I've been thinking about. Welcome to the weekly live stream. In case this is the first time that you've ever been here, I want to let you know that this live stream is organized around a math problem that I've been thinking about lately. You see, math is actually something that's part of everything that we do in life, especially when you're trying to do maybe some problems that are important. A lot of people are thinking math is just for homework, but no, there's a reason we do all of that. So I have a question for you today. But we have 45 minutes. The way we usually do these weekend live streams is that I'll introduce a question for you, and I'll give you a chance to think about it. While you're thinking about it, I'll make some comments about the problem to parents or coaches who may be watching to maybe explain how I come up with these questions. Then I might make a few comments about mathematics and maybe how math is related to the world, the present world. And then after that, I'll open up for questions and answers that could be about anything. Well, when I say anything, what I mean is anything except specific math problems. And that's because we have our daily live streams in which I answer very specific math problems that you might have that you want to ask. These weekend live streams are more general because we know that we also have a very general audience watching that might include parents and coaches too. And so these will be general questions about learning. Is everyone ready? I have an interesting question for you that was actually on my mind today. Try thinking about this one. Suppose that you have a geostationary satellite. That means it's a satellite that's always above the same point on the Earth as the Earth is spinning. Now, this geostationary satellite orbits the Earth at 22,236 miles above the equator, and it's always above the exact same point of the Earth. That's why it's called a geostationary satellite. Geo is like the Earth, stationary is at the same point. Now, the equatorial radius, the radius of the equator of the Earth, is 3,963 miles. The question is, relative to the center of the Earth, how much faster is the satellite traveling in miles per hour? Round your answer to the nearest thousand. I want to warn you, this question is not, the picture is not drawn to scale. Actually, this is about 22,000 miles, and that's only about 4,000 miles. So it really should be over there, but then you just wouldn't get to see the satellite. Okay, so this is the question. And while students are thinking about this question, I'll also make some comments to parents. Of course, the ideal is that if you think about questions, you focus and you think about the questions. So if you are thinking about the question, please do. On the other hand, if you are a parent or coach, I want to tell you a little bit about what's behind this. You see, this is something that I've been dealing with right now. It's something related to GPS. GPS satellites, of course, aren't geostationary. GPS satellites actually do make progress revolving around the Earth. However, it's a very natural question to wonder, how fast are these satellites moving? And what is GPS anyway? And by the way, that's what makes a good question. A good question is one which has some math inside it, and also maybe has a story, and something that we can say afterwards too. But it's also important to give a question for which there are multiple ways to solve it. You see, at first you might try a brute force method of saying, well, I can just go and figure out how fast is that point on the surface of the Earth moving? And then how fast is that satellite moving? And then I could subtract them. But that wouldn't be interesting. You see, I have a hint for you. Actually, you don't need to figure out the speed of a point on the Earth if you want to play about this question. So, a good question is one where there is a standard way to do it, and there's a clever way to do it. And that helps us to appreciate why the clever way is clever. And students, if you haven't figured it out yet, the question's still here, don't worry, it's not too late. And you can still play with it, but now you have a hint. And for parents and coaches, that's my feeling too. It's very valuable to give questions for which you can give hints along the way. Because as you have hints, those are the way to really learn how to think. Because it's not important to just be able to do a problem that someone gave you. It's much more important to look at a question and to be able to think about what you might use. Because these are awful numbers. Why would anyone want to use this horrible, horrible number here? This 3963. That's no fun. I personally love nice numbers. But the good news is that there's actually always two hints to every question that I give. You don't actually need to use the radius of the Earth. It's always fun to see that there are ways to solve questions when you don't have to use all the information. But by the way, the world is that way. The world is complicated. There are a lot of numbers in it. And you don't have to use all of them when you're trying to solve a real problem. And so in this one, now I've given you the 2 hints. For parents and coaches, this is usually what I would do if I'm teaching somebody. I feel that if you architect 2 hints carefully, if someone's thinking, they might be able to figure out how to do it. And whether or not they figure out how to do it, after that is a good time to maybe discuss the mathematics behind the problem. And then that will also let us maybe learn something kind of cute. You see, this question I like because it's an example of a question that could even appear in like a American math counts competition, like a countdown round, something where you're trying to do it as fast as possible. Because it turns out a question like this is possible to do very quickly. The trick, of course, is to think about how can we do less calculation to actually figure this out. Let me switch to my chalkboard. So we had some number of miles. Actually, on this kind of question, the number of miles is not really the most important thing. But it's going to be some number of miles, which is how far away, how far above the Earth that satellite is. So we have the Earth. I guess this is the Earth. And if we want to draw the Earth in a way that's to scale, well, I guess I should actually put that satellite very, very far away. Does anyone remember how far away it was? That's actually an important detail. Oh, that dot is not very good. Let's draw it better. Does anyone remember how far away it was? How far away was that dot? This dot was, yes, I see that people are remembering. Wow, my goodness, how can you remember these numbers? You guys must be good at the spelling bee. 22236. This is how many miles. Now, yeah, I see this is very interesting, by the way. A lot of people have already put in their head, it's around 22,000 miles. And that, by the way, is the most important part of it. I have the whole number here, so I'll just leave the whole number here. But, I see. Temp ID wrote it down. That, I guess, is a fairly good way to remember the number. But in any case, the important thing is that we wanted to know roughly how much faster that satellite was moving than the point on the Earth. And so, roughly speaking, it's 22,000 miles. But okay, so now the question is interesting. It says how much faster is the satellite moving than the point on the Earth. Did you realize that the answer was a trick question? It's 0? Well, no, it's not a trick question. It's a geostationary satellite. So of course it is right above that spot on the Earth. But I had said with respect to the center of the Earth. And as you may have seen in one of our daily live streams, maybe it was this week or last week, I forgot which, but one of our daily live streams, we found out that actually if you're on the surface of the Earth, you're moving pretty fast. I seem to remember it was on the order of like 1,000 miles per hour. And I remember somebody commented in the comments like, I am speed. But you see, we don't need that here. There was a hint that says you might not need to know the radius of the Earth. And because of that, I'm going to show you that when I do a question like this, before I put any numbers in, some people remember that I'm speed. Before I put any numbers in, I want to put some letters in and see which of the numbers are important. So you told me it was 22236. But I'm going to say the distance, this distance is going to be d. D stands for distance. That's the distance that the satellite is from the surface of the Earth. What letter should I choose for the radius of the Earth? I'm guessing maybe this should be r. I don't have enough space to write the r inside the circle, but that's the radius of the Earth. So now, if I have a d and an r, how would I find out the speed that a point on the Earth is moving relative to the center of the Earth? Well, this is something we had done in the daily live streams, but whether you were there or not, you can probably figure this out. A point on the surface of the Earth, let's write that more neatly. It's going to move at one whole revolution, one whole equator revolution, every hour? No, every day. Okay, so the point on surface moves. One whole revolution is 2 times pi times r, miles. Everything is in miles. Maybe I'll write it in miles. Miles per day. Okay. Now, if that's the number of miles per day that a point on the equator moves, a point on the surface moves, how many miles per day? Well, let's say how many miles does that satellite move in a day? You see, it's still another circle, right? the way we're doing things is that somehow these are circles. It's 2 times pi times r. And by the way, I guess I'm already showing you the quick way, but my hope is that when you were trying to do this, maybe you even worked out some of these numbers and you found out that you are speed. Because if you go and figure out what this is, with r being approximately 4,000, you're actually moving like about 1,000 miles an hour if you're on the equator, which is amazing. But it turns out you don't need that. Because what we do next is we find out what is the speed that the satellite is moving. Well, satellite moves 2 times pi times the radius of the circle that the satellite gets. So the satellite's radius of the circle is r plus d. That's important because it's not just d. D is the distance above the surface, right? So if d is the distance above the surface, I still need to add an r. And that's miles per day. So therefore, what this shows is that if I want to know the difference in my speeds, I actually don't need to know the r. If I subtract those two, that's the beauty. That's the magic in this problem. The difference in speed is just 2 pi times r plus d minus a 2 pi r. 2 pi times r plus d minus 2 pi times r. And the 2 pi r plus d is just 2 pi r plus 2 pi d. That's 2 pi r plus 2 pi d minus the 2 pi r. And so all that's left is 2 pi d. Hooray! So all I need to do is 2 pi times d, and that's going to be the speed in miles per day. You're probably not used to thinking of speed in miles per day, so we should change it into miles per hour. And indeed, this is nice. It's like I don't need to worry at all about this horrible number with it, which had a 3 and a 9 and whatnot. And I also see some people have figured out the answer. Okay? So if I do 2 times pi times d, and that's miles per day, I want miles per hour. Can someone tell me what you do if you want to go from miles per day to miles per hour? It shouldn't be 2 pi d. It should be something else. This is in miles per day. So how many miles per hour? Not 2 pi d. Thank you very much. Divide by 24. Actually, on these things, I see some people, like if you say times 24 or divide by 24, that's always a good question. I'm always afraid of doing this wrong myself. Okay? And I'll tell you what I do. I guess I left too much space. But anyway, what I like to do when I think of should I divide or should I multiply is what makes sense. If someone told you your speed in miles per day and you want to know miles per hour, it should get bigger, right? Because there's a lot of hours in a day. So somehow if I go at a certain number of miles per day, my number of miles per hour should be times 24. Oh, wait. Just a second. No. That's the other way. I just got it backwards. I just told you the thing backwards. Because that's how I would check. That's how I would check of like what makes sense. It's like if I had a certain number of miles per day, then in an hour it's less. So it should be divide. It should be divide. And this is just showing how it's not valuable to kind of memorize an answer one way or the other. You just tell your story to yourself and say, if I had something which is a longer period of time, and that's how many miles per day I went, I should divide to find out how many I went in a shorter period of time. Okay, great. Yes, that's right. And actually, I should say, everyone makes mistakes. And the valuable thing is that if you explain through what you're doing, you often will catch your own mistakes. And so that might be a suggestion for you guys as well. But now I need to figure this out. So I've got 2 times pi times d over 24. And so my d was this 22236. How am I going to do this? What should I use for pi? I have to go and plug some numbers in, right? I have 2 times pi times d. Let me write that down. So now I need to figure out 2 times pi times d, which is 22236, divided by 24. What's a good choice for pi? Aha. So 3 is going to be maybe a bit dangerous because pi is not quite 3. Although 3 might not be that far off given that we're comparing to like number of thousands. On the other hand, 3.14 is no fun. 3.14 is just like too many digits to multiply by. And I saw some people here said 22 over 7. I chose this question because I also had a math thing to show you, which is that when you're doing fraction things with pi, and when you're trying to approximate, 22 over 7 is more efficient than 3.14. I don't want to multiply by 3.14. but 22 over 7 might be okay. And the other thing to know is that 22 over 7 is actually closer to the real pi than 3.14 is. We talked about that actually in a previous live stream. But if you are curious for yourself, you can go and compare. You can look at pi, you can look at 3.14, and you can look at 22 over 7. And 22 over 7 is actually closer. Okay? So let's try this. What do we have? So this is equal to 2 times, let's do it this way, 22 times 22236 divided by 24 times 7. Whoops. So indeed, I have my 22 over 7 appeared there. I have a 2 over 24, 22236. Good. Now let's multiply this out. No, don't multiply. Whenever you see stuff like this, first try to cancel out common factors. Okay? Common factors. What kind of common factors can I cancel? Well, I see that there's a 24 here, which makes me want to cancel out a 2 and leave a 12. But I see that I can still keep canceling. There's a 22 there. That should become an 11. And this should become a 6. And I thought it was kind of cute that this 22236 is actually divisible by 6. The reason I know that is because there's a rule for divisibility by 6. It's even, and the sum of the digits is a multiple of 3. I don't have enough time in this particular weekend live stream to talk about that. That's something that would go in a number theory course. And for example, that's what we chose to talk about in our official number theory course in the daily challenge. You can learn that anywhere online though. It's a very standard trick. Let's divide. If I take the 6 into there, 22236 divided by 6 is how much? You guys will probably be faster and more accurate than me on this one. 6 times 3 is 18. 6 times, and then there's a 42, so 6 times 7 is 42. I think it's going to be 3706. Is that right? Let's double check to see how everyone's doing. Aha, 3706, we agree. So now I just have to go and do this. 11 times 3706 divided by 7. Roughly how big is that? Let's go and figure this out. At this stage, I guess, some people use a calculator. I'll just go ahead and do it. I mean, it doesn't look like it's going to be the end of the world. The interesting thing is I'm looking at that 3706, and I see that 3706 times 11 is going to be approximately 40,000. Do you know how I know that? It's because I multiplied 37 by 11 in my head. There's a trick for multiplying by 11. If I want to multiply a number by 11, let's just do this one really quick. 37 times 11 is 7373. Look what I'm doing. I put the 3 here, I put the 3 here and the 7 there, and I put 3 plus 7 in the middle. And 3 plus 7 is 10. Oops, it has to carry. And because it has to carry, it gets 407. But that's how I can look at this 37 and know that 37 times the 11 is going to be 407. Actually, I'm doing some mental math. I mean, I just saw that would be the 407, and then I should just put a 66 at the end. So it looks to me like the top is just 40766. Am I actually right here? Maybe I made a mistake. That looks good. Let me tell you how I did that. Because 3706 is 3700 plus 6. The 3700 times the 11 gave me 40700. And then the 6 times 11 gave me 66. So it worked. But you'll also see that this part wasn't even that important. Who cares about the 66? I'm rounding to the nearest 1,000 anyway. That's why when I looked at it, I was like, the top is about 40,000. Divided by 7. Now the question only asks me, round it to the nearest 1,000. So if I look at this, it's either going to be, 7 times 5,000 gives me 35,000. 7 times 6,000 gives me 42,000. Which is closer, everyone? Is it 5,000? 5,000 times 7 is 35,000. 5,000, or is it 6,000? 6,000 times 7 is 42,000. Which is closer? This is actually what I'm doing also to cheat again. I don't actually want to do that long division. I just want to say, come on, it's going to be either 5,000 or 6,000. I'll choose the one that's closer. And 42,000 is indeed closer. So the entire answer to the whole problem is 6,000 miles per hour faster. So this is an example of a fun question. Maybe tell you a little bit about then where this thing came from. Why did I even choose to do this question? Well, I wanted to do this question because it shows that sometimes when you have a problem, you can throw away information and you can still solve the question. It also shows it's really valuable to do what we just did at the beginning. At the beginning, I was very careful to not actually use numbers. I wrote everything with R's and D's and pi's. When I was doing middle school math contests, sometimes I'd make the mistake of doing everything with numbers. And if you do everything with numbers, you don't know if you're doing extra work. In this case, that was extra work. Because once we figured it out, you only had to do 2 pi times d and divide by 24, not multiply. And then after that, we had some fun arithmetic tricks. I wanted to talk about arithmetic tricks also because I know everyone likes to use calculators, but it's always lots of fun if you can beat the problem yourself. It actually feels very satisfying. Now maybe I'll move to the next part of this talk, which is this particular live stream, which is maybe a little bit about math and what the relation is with the world or why this question even came in the first place. So this question came because I've been thinking about, as you know, about trying to stop COVID-19. I've been doing things with apps, and at the same time, I've also been thinking a lot about GPS. So what is GPS? GPS comes from satellites which are moving around the Earth. And it was very important to me for some of the things I was doing to understand what was the speed of light, to understand how fast information can flow from a satellite to the Earth. And I guess I was even kind of curious, how fast are those satellites moving anyway? And the answer is, pretty fast, 6,000 miles per hour, something like this. But it's not like they're moving like the speed of light. I was actually just kind of curious how fast these satellites were moving as they were going around the Earth. And in general, mathematics has a lot to do with a lot of the things that we are actually trying to do. In fact, I went and even looked at how GPS worked. The way that GPS works is very interesting. GPS is based on geometry. It's based on 3D geometry, where every one of those satellites has a clock that's ticking, and it's always telling you what time it is at that satellite. And then you just go and see how long does it take for that signal to reach you. And that will tell you how far away the satellite is. That's pretty cool. Like the fact that somehow the satellite's telling you, hey, right now, it is 7:22 p.m., 8:22 p.m. It will take that long for it to get all the way to you that you can figure out how far away the satellite was. And then after that, you use some geometry to figure out if I know my distance from all these satellites, where am I on the Earth? This is just an example of what I do on a daily basis. It's like I think about math, see if I can use it for the world, and because every single Saturday I need to make a problem for this live stream, what I end up doing is the problem I give you is maybe something related to what I've been thinking about. Now that moves into the last part of this live stream. The last part of this live stream is just a Q&A session where I'm happy to answer any kinds of questions that you guys might have. And these questions are intentionally going to be not specific math questions. Specific math questions, please reserve for the daily live stream. This is a chance to ask about anything. And as you know, if you've watched enough of my things, I'm interested in lots and lots of different things. And I hopefully can represent mathematics and mathematicians from many perspectives. I see a question already. Po-Shen Loh is not on the App Store. No, and that's because I need your help. The reason it's not on the App Store is I've not yet been able to get in touch with somebody from a medical institution who is willing to chat and to help us have a letter of support, just saying it would be great for this app to go into the App Store, and we've looked at the app and it actually is reasonable. It's not telling people false things about medical situations. That's what we need, because we don't have that yet. We actually aren't there yet. And that's actually an interesting lesson too. This is not just about math. This live stream is also about being people. A lot of times when you're young, or maybe you think, all I have to do is learn math, and if I just learn math, I can do anything I want in the world. Absolutely not. I did a lot of things with math up to this point, and at a sudden stage, it has turned into a mix between something called politics and another thing called relationships, and trying to build working relationships with lots of different kinds of people. So I strongly encourage all of you, math is great, it's good to learn math, but also make sure you invest enough time building relationships and learning how to be friends with as many people as possible. It's useful. Other things. Oh, this is pretty interesting. Shireen Zhang asks, what is the best way to learn math without staring at a screen or paper? Melody. You have a nice name, by the way. And actually, that's what I often did. I would listen to a melody. I mean, I would sit in a chair. So I would first look at a piece of paper or look at a screen and get an interesting, hard problem. And then I'll just get in a comfortable chair and sit down and think, how might I try to solve this problem? You see, that's the difference between a hard problem and just like a normal problem. A normal problem, you don't need to go and sit down and think, do I know how to solve? You have to actually go and try to do it or stare at the screen of your computer or type in some calculator. But if it's actually a question worth thinking about, you kind of take a step back and you say, how might I do this? And you put on some music and you listen to the melody while you think about the problem. And it's actually really enjoyable. And the way to find these kinds of problems is, I'd recommend, move through this hard math, go and learn about the math that's, I would actually recommend competition math, middle school competition math. But after you can do those, go and try these things called the AIME problems, American Invitational Math Exam. Those are hard, but those are the kind of questions you kind of have some time that you sit back and think, how might I even start doing this question? And then that will prepare you for the questions you'll see in the real world. Aha. What else do we have here? Oh, that's interesting. Alan Han asks, how do we get a good future? From you. You're the future. This is actually why I give these live streams. These live streams are not like for profit. These are free. Why am I giving live streams to people who are maybe in their teens or relatively young? It's because you are the future. And I need you, and all of us need you to be the future and to do great things. And I personally know that there are many, many, many people in this world at the age that is watching this live stream, of the students, many people of this world who maybe think of math as something that you just do to do, and then maybe you'll get into college if you do it. And if you do that, and if that's what you do through your life, you unfortunately won't contribute as much to us having a good future. But my hope is that through these live streams, at the age that you are right now, you'll start to see that, this math is related to everything, like physics, astronomy, everything. And you pull everything together at the same time. And then someday, maybe when there's some kind of a future crisis, maybe you'll step up. And that would be great for everyone. So the future is you. And I mean that. More questions. Oh, wow. Krypton BTW says, how do you deal with rejection and failure? Let me tell you, I have been dealing with rejection and failure for the last 5 days. I'm being completely frank. It's because after we made Novid and released it onto Facebook, immediately it became, Google says, no. I'm not powerful, right? Like, I don't have $1 trillion. So somehow it's like, what are you going to do? Oh, well, Google didn't just say no. There's an important lesson in the world, which is that it's very hard to get a no that's like, there are very few no's that are really like no. You can often try to find out if there's any other thing you can do. And that's when I started to find out, we need to get some support from medical institutions. So then you go and start to go and reach out to medical institutions. You reach out to your local city. I've been reaching out to Pittsburgh. You reach out to hospitals. You reach out to all the friends that you've made ever since you were in middle school. Like everything. And so, yes, I've actually so far not succeeded yet. But as you can see, I didn't give up. And there's something that's very, very important, which is called, it's important to know what's worth doing. And once you've figured out something that's worth doing, you don't give up. You just keep going. And that's actually the hardest thing, because normally it feels bad. And it's like, oh my gosh, it didn't work. I feel so awful. It's like this person said no. That person said no. They say to your face, no. You need to actually have a ability to let lots of people say all kinds of things to you and be like, well, it's still worth doing, so I'll still do it, right? And the way that you have this is by having a different mentality of knowing that the problems worth solving are the hard ones. And so once you know the problems worth solving are the hard ones, you just say, yeah, but if I just get one yes that unlocks this ability to go through and do one more step, we got a huge gain, because anything that's hard is worth a lot. So basically my advice to you is pick and choose. Go and try to do the things that are actually hard. And then just don't give up. Just keep fighting with it. And that's how you deal with the failure and the setback. You'll just know that what you're trying to do is worth it. Okay, more questions. My moderation team here also has helped me to pull out a few questions that I want to hit. So, that's interesting. Bombi Marshmallow, you've got a cute name, says, how can a satellite go as fast as the Earth? Well, you see, satellites, or things that are in space, could actually go even faster than the Earth. How else would we manage to make something that goes all the way to Saturn? Well, actually, that doesn't prove that you go faster than the Earth. But Nevertheless, it's possible to go very, very, very fast. That's what the principle of rocket propulsion is. So they're not, for example, just with propellers or jet engines flying in the air. They're using generally like hydrogen and oxygen, mixing them together, making the whole thing blow up, and having all this hot gas go out in the back. That's the principle of rockets. And actually, if you want to be a rocket scientist, all you have to do is to learn a whole lot of math, because there's a lot of physics in there. And then maybe someday you will be able to say, I am speed, too. Other questions? Oh my goodness. Tina Tia asks, will we ever blow up the moon? I hope not. Please don't. I don't think that would be productive. And that's also another question, which is called like, whose property is the moon anyway? I'm not sure it's any one country's property. Therefore, we should probably not blow it up. Okay, more questions. Winston Leong asks, do you think COVID will end the world? No, I don't. And that's because I can use mathematics to see this. You see, when you use mathematics to look at the world, you start to notice stuff. And when you see that, some pretty big percent of people survive COVID, then you see that it's not going to end the world. It's like there will still be a large percent of people who are left. But unfortunately, there's also a large percent of people who die. And so that's a disaster. And what we want to do is we want to make sure that doesn't happen. So it won't end the world. However, it will be not pleasant. I will say, though, it's probably going to change our entire way of life. I think that I myself am going to miss the former way of life. The former way of life was one where you could travel anywhere and you could do all kinds of interesting things and meet people. I would not be surprised if the future way of life involves much, much, much more online communication. And so I guess you are the interesting generation where you will be the first to kind of turn into one which can completely interact online. That is both a good thing and a bad thing. You will be more fluent in everything online than everyone else. But on the other hand, it will be maybe a little bit less personal. So I think that the world will change fundamentally because of this. And hopefully we'll find ways to use the internet to communicate as if we were in the same room. Okay. What else can we say here? Mr. Dark says, how to deal with lack of motivation. It's a real problem, right? I mean, motivation is that fire from inside. And my hope, by the way, of running these live streams is I can provide some motivation to everyone. In fact, that's why I have daily ones too. My hope is to be able to give a little bit of motivation all the time. And if you can see, motivation comes from having a feeling that you're going towards something that you want to go towards. And how would you know that you're going towards something you want to go towards? It often helps to maybe have a dream or a mission. In fact, I think that life would not be very exciting if there wasn't a dream or a mission. If all you do is you kind of go through the motions to do something and hope that someday you have freedom to do whatever you want. And then when that day comes, to not know what you want to do. I think it's much more interesting to always be inspired and motivated by things. For me, in my entire life, even now, I'm always inspired by people who have done much, much more than me, whether it be in mathematics alone or in the real world. And I kind of like to see what they're doing. Like everyone talks about like following some celebrities, or in my case, I like to follow people who have done great things. And that's very motivating because I'm not anywhere near that. It's true, I'm not anywhere near that. And it's probably that I'll never get anywhere near that in my entire life. However, it gives you something to move towards. And so I recommend that you do the same thing. Let's see, what else can we have here? Oh, this is interesting. Okay. Oh, this is an interesting question. So, Severus Antonius says, in quarantine, how should I use what I have to therein be, how should I use what I have to therein be in content? So I'm not entirely sure what your answer means, what your question is, but I'm going to interpret it in the following way, which is that, in quarantine it can be lonely and there might be not so much around you. That's where I would say your ideas are really valuable. And that's where if you can learn to do things with your head and to come up with ideas, or to learn to do things with your computer and to build things, you will actually be very motivated and very busy. And I think that that's actually an important thing. It's that sometimes if you are not able to do the things that you normally were doing, that is an opportunity to try to do something else. And I've noticed that somehow in quarantine, if you focus on the fact that there isn't anything, then indeed it can be extremely dull and boring. But on the other hand, if you go and say, I have a new project, I want to understand something, or I want to read this book, or I want to build this thing, then it can be a lot more helpful. And another thing I recommend is the social network. The thing that's very hard in quarantine right now for social beings like humans is that it's hard to not get people to talk to. And so hopefully, I mean, one of my hopes by running these kinds of daily and weekly live streams is that we can at least have a little family that we can bring around on a very frequent basis. The fact that I can recognize so many of these usernames is showing that I think we are trying to all get through this quarantine together in some sense. What other questions? Oh, that's a cute one. So Yasha Gao asks, why is coronavirus called COVID-19? Oh, it's because the COVID stands for I think it's like corona, Rona. V is for virus. Actually, sorry, VI is for virus, and D is for disease. And the 19 is that it came out in 2019. And the hope is that it won't last until 2021. We'll see. Okay, more questions. Let's see. Oh, I see that we have a robot here. Hello, robot. What else can we do here? Oh, Pi asks, what's your favorite sport? So I actually like playing ping pong. I mean, I also walk around, I ride my bicycle. I used to. Nowadays, it's a bit more dangerous, so I drive my car. But I actually really like ping pong. And the reason I really liked ping pong is because it was a sport which I could try to come up with my own strategies to see if I could do weird stuff, like whack the ball as hard as you can. And, I had fun inventing my own very, very strange techniques. But this is also showing a little bit of game theory, because my point is whenever I wanted to play some game, it was only interesting to me if I can come up with a really weird strategy that other people would not be expecting. And I give that advice to you too. Whenever you go through life, try to come up with your own strategies. Don't just copy other people. Other questions? Yu Ming Su asks a really good question. How do mathematicians make money? The best way to make money as a mathematician is to not be a math professor. You should actually go and use your math to be like an applied mathematician, working as a researcher somewhere. Maybe you could go to Wall Street. Maybe you could help with people who are modeling disease. All of these things are great ways you can make money. Actually, if you're a professor, you can make money too. That's also true. But in general, the reason I gave you that answer is that many of the people who are mathematicians are not really thinking about this like making money part, because most mathematicians are lucky enough that they have enough money. Like they have enough money to support themselves and their family, and that's good enough, honestly. You don't actually need to have a huge amount more than that. Unless, in my opinion, the only time that it's really interesting to have more money is if you have like enough money to change the world or save the world. But usually you don't get that kind of money by being like working in a job anyway. And so what I would say is if you want to do math, you will certainly have enough money to support yourself and the people that you care about. And on the other hand, you will also get to do something that you love thinking about. Other questions? What can we do here? I'm looking at all of these different things. I see that there are lots of different questions, some of which are more on the personal side, some of which are more like maybe you could learn something. I'd like to go and try to talk about these things that could be somewhat reasonable and useful for learning. So I think I saw a question saying, how can you not procrastinate? I think that's a good question, by the way. This is about study skills now, right? Because it's one thing to know how to do math, but it's another thing if you just procrastinate all the time and then you don't get anything done either. So procrastination basically is like you just feel like doing some other things first that are like fun, perhaps. And then you wait until it's too late and suddenly it's, oh no, how am I going to get all of this stuff done? So I think the main thing here is just a question of what is fun, right? If the thing that is fun is doing something that's hard, I don't even know if I'd call that procrastination. I would call that a good thing. It's actually not a bad thing to make sure you reserve enough of your day to think about something that's hard, rather than to just use your entire day to do normal stuff. So for example, if you have homework from textbooks, from normal textbooks, it's not actually a good thing to just spend your whole day just making sure you did that homework. It might be a better thing to, while you're fresh, go and think about something hard. Make sure that for some good chunk of your day, half an hour or a whole hour, think about something hard. And then after that, then do your homework. So I mean, at that point, it's not necessarily procrastination, because it's not like you were just playing some game. It's like, you were trying to do something good. And then by putting them in this order, you actually made sure that you didn't spend too much time doing something that was normal. And this is something that I've always been doing in my life. Well, actually, not always been doing. In my last 10 years, this has been the way I usually operate, where if there's something that's routine but needs to be done, I will know in my head how long does it actually take to get that done well. And then I'll make sure that I have enough time for that. But then I'll also make sure I use all the rest of the time to do something really hard and interesting. So I encourage you to procrastinate, but by doing something really hard. And then, of course, make sure you get your real work done too. This is cute. So Elena Lee asks, how many times do you grocery shop a week? Well, our family goes approximately once a week, and that's just to save time. And I'm talking about time management now. Like, I'm trying to use this particular weekly live stream to talk about these like study habits, or like what should we do to try to do the most with our time. You see, if you go to the grocery store every day, number one, you're going to waste a lot of time, just like driving there. All that takes time. And also, number two, you might get COVID-19. Serious. So actually what is much better to do is just to say, take one shot. But you see, this idea of thinking about how to use your time is also very valuable, because a lot of people who are very capable are often very capable, not only because they're clever, but also because they're very, very careful about how they give their time to different tasks. And I'll give you some tips from my own life. There are some tasks that I know that I can do when I'm very tired. And those are like replying to random emails. And so oftentimes I'll wait until it's very late and I'll do that. There are other tasks that I know that I can only do when I'm on the bus. I don't ride the bus anymore, actually, because I'm afraid of potentially catching the virus. But I used to ride the bus all the time. And when riding the bus, that was exactly when I deleted all my emails. You see, deleting emails still takes time. You've got to open them and whatnot. But on a bus, I can hold up my mobile phone and just go, right? Just like knocking them all off, or open one and close it. But I'm just simply trying to show this like very careful idea of my time. There's not enough time in this day for me to do everything I want to do. How to make sure I allocate that in a way to get the most done. The earlier you build this ability, the more you can do. More questions. Let's see. Just opening the thing so that I can see what my moderation team also put out. Oh, that's interesting. Shirley Joe asks, how do you switch interest from English to math? You see, in my head, I think that English and math are both intellectual subjects. So I think they're actually both pretty interesting and both very useful. These days, I spend a lot of my time using math to think about how to write English. You see, when you are in the grades which are younger, maybe like first grade to fifth grade, a lot of the English is involving reading. But eventually, when you get into high school, and then much later, most of the English you're doing is writing. And actually, as you write more and more things, the important thing about good writing is you need to be able to figure out what is your point and how to prove your point. And you got to figure out how to do it as efficiently as possible. There's actually a lot of thinking in there that has some thinking that's similar to mathematics. So whenever I write, it's actually a very logical thing. Maybe the way I came to thinking this way is because I was involved in the debate team when I was in high school. And there are a lot of people who do debate who are also interested in math or science. And that's because that's all about logic. And once I saw that, I saw the connection between English and math. That's how I went from the math to the English direction. But then what I'm telling you is if you're going from the English to the math direction, I would say if you find yourself trying to write something that's compelling, that convinces people, the best way to do that is with logic. And your logic becomes far, far better if you also learn math. And maybe you can go from English to math through the debate direction. Like that's a bridge for me, because that's like being very, very logical. So my advice would be, think about how you can use your English to logically write. Think about how you can use your English to logically read. And as soon as that logic comes in, you're getting into the door of math. And maybe what you're thinking is, but that doesn't look at all like y equals x squared. And it doesn't look at all like some like sine or cosine of x. That's because that kind of math is the traditional curriculum math. And if you want to get into the thinking math, my advice is to play with these middle school math competitions, where you might just be doing a problem about a satellite going around the Earth. It's not super sophisticated, but there's a lot of clever thinking that you can do on top of the basic concepts. Let's see how our time is. I think we have time for one last question. I saw somebody asked about complex plane. That would be more suitable for one of our daily sessions. What else do we have here? Looking to all of these to see what would be the best. Okay, let me close with one. Somebody asked, what are my thoughts on artificial intelligence and how it might change the world? To me, artificial intelligence is a consequence of one very important technological development, which is that we now have computers that can calculate at gigahertz. A gigahertz means 1 billion operations per second. So the simple computers that we have every day can do calculations which are doing about 1 billion of them every second. And the kind of calculation that they can do in 1 second is like adding two numbers, each of which has like 20 digits. Now, if you ask me to add two numbers, or actually they can also multiply. If you ask me to multiply two numbers which have 20 digits, I don't think I can even do that in 1 second. It might take me a while, maybe a minute. So if you look at this, you see that somehow one computer, or even one smartphone, like one little phone with no internet connection, it could do work approximately 10 billion times or even 100 billion times as fast as a person. And that's what made artificial intelligence possible. It's because it's inexpensive. You can buy a computer and it'll cost $1,000. And suddenly you have something that's operating 10 or 100 billion times as fast as a person. A person, by the way, if you want to hire them to work for you for a whole year, you might have to pay a few tens of thousands of dollars, or maybe even $100,000. And at that point, if you were going to buy computers, maybe you could have 100 computers. So now we're suddenly talking about being able to do things 1 trillion times as fast as a person. And that's the core of artificial intelligence. It's not really that the computers are smart. It's just that they're 1 trillion times faster. And so artificial intelligence is about how far can we go with that. And if you ask me, my opinion is that'll get you some distance, but it won't solve all the problems in the world. Because there are some problems in the world which cannot be solved just by brute force. For example, if I'm trying to invent a new solution, a new method, that's not something I can just say, just do it 1 trillion times faster. On the other hand, if I came up with a way to figure out who might be infected based on who has pressed report on their Novid app, the app we're doing to stop COVID-19, well then, I can write a computer program, and that computer program is going to go at like 1 billion times as fast as me, which is great because there are 1 billion people in the world. So that means that I can actually do the calculations that I need to do for all the, well, there's 7 or 8 billion people in the world, but I can do all the calculations for all the people in the world without having the computer break a sweat. And so the point is the artificial intelligence will help you get a few questions done, many questions done. But the most core questions of creativity, problem solving, how in the world to invent the crazy technique that would be useful to solve these hard problems, so far it seems that humans still have the edge. Well, that's hopefully a positive note to end this weekend live stream with. We won't have a session tomorrow because we don't have sessions on Sunday, but otherwise I'll have a session again on Monday. If you liked what you saw, I have noticed that we had close to 300 people in here at some point in this live stream. My goal is, of course, to reach more people. And if you are a parent or a coach, if you thought that this was interesting, please do help spread the word to other parents and other coaches. Because the way that I'm making my decision of whether or not to keep doing these is basically looking at the numbers. As you know, I care a lot about impact. And so if we can have bigger numbers, then we'll know that this time is time well spent. With that, I wish you all a very happy weekend, whatever part of the weekend you may be in right now. See you next time.